3 more postulates to go. The first one, or postulate number 3, collisions between gas particles and other gas particles and between gas particles and the walls of a container are perfectly elastic. That means there is no net loss of kinetic energy during the collision. Kinetic energy is conserved. If you had the physics course before this, we did talk about inelastic collisions and elastic. Now, this is not strictly true. There's actually no such thing as a perfectly elastic collision, but we're close enough to make the assumption so we can figure out the behavior of gases. The fourth and penultimate postulate, gas particles are so incredibly small, you can see them, the little dots there, compared to the distances between them, that we will ignore the volume of the particles themselves. We'll assume they're zero. So the volume of the container is essentially the volume occupied by the gas. We're not going to worry about the teeny tiny volumes taken up by each individual atom or molecule. And finally, we will assume that intermolecular forces, and remember we had a whole unit on this, whether they're repulsive or attractive, are assumed to be so weak that particles exert no forces on each other. Right? Here's a very strong ionic bond. This is very strong. And then the dipole-dipole bond between them is much weaker than the bond holding the hydrogen to the chlorine. So for the purposes of this theory, we're going to say these bonds don't exist. This is a great chart that summarizes the 5 postulates for kinetic molecular theory. First one has to do with the kinetic energy. Second one, the average kinetic energy is proportional to the Kelvin temperature. Here's our elastic collision one, and I'm not reading these. I'm hoping you can read through them. And if you have questions, just go back a few slides. Gases occupy negligible amount of space, so the volume of the container is the volume of the gas. And we are not going to worry about intermolecular forces. We'll assume they're much smaller than the forces bonding together the various molecules, and we will ignore them.